Hello everyone, and thank you for attending today's webinar regarding ShipConstructor structure. My name is Norman Eldridge. I'm Senior Product Manager here at SSI. I'll provide a brief introduction of the product, and then we'll dive into the core of the session regarding demonstration. Basically, this is part of our SSI user webinar series, an ongoing series intended to introduce and demonstrate our products. Session is part of an ongoing series. The audience is primarily intended for ShipConstructor users and designers and their managers. The key takeaway is up-to-date awareness of this product, its key capabilities, and benefits. That's the main motivation for this. Today's product demonstration will be by Blair Johnson, our Technical Product Manager. You'll hear from him later on. And we'll have available for questions and answers, either during the session or after the session, will be Chris Emerson, our lead software developer for Structure, as well as several other products. A few weeks ago, we had a session regarding hull, ShipConstructor hull, and this is a natural follow-on to that presentation, where basically we're taking it from initial design and going to basic design and detailed production design. And one thing we're seeing in terms of trends, increased interest to perform the basic design and production design to be accomplished with the same tools. This work not necessarily performed within the same organization, but is frequently distributed within and outside of the organization today, as I'm sure you're all aware. We're also quite aware of the shorter design and production cycles, so it lead directly to shorter project payment schedules tied to milestones and deliverables. So there's a lot of, anytime we can optimize the flow between the phases of a project, we can shorten that development cycle, cost benefits are substantial. What is ShipConstructor structure? Well, it's the data designed in the external hull production model flows freely into the structure product from initial design into your basic design. And finally, we're getting into the detailed design for ShipConstructor structure. The structure offers rapid 3D production detailing of the internal structure, of course. It combines aspects of both associative and parametric 3D modeling. It's tailored specifically to design of ships and offshore structures. Their main value propositions, the accurate and intelligent 3D project models can be created very quickly utilizing a cross-section of shipbuilding specific capability of ShipConstructor and the native AutoCAD tools. So anyone familiar with AutoCAD can quickly get up to speed to use ShipConstructor structure for shipbuilding. Again, I'm sure you're aware of that. Some of the key features that we'll present today and discuss, and you're free to ask questions. Defining internal plate structure, profiles and extrusions. Number of automatic features would generate part names from build strategy and other data. Add stiffer to cutouts in intersecting parts. Add required beveled information. Associative marking for piece marks, and etc. Define planking sections. Apply extra material to part boundaries. Create 2D workshop and class approval drawings, 3D assembly drawings, 2D profile plots, and sketches. So these are a number of the key features of ShipConstructor structure, to name a few. Well, now I'd like to be able to hand off the presentation to Blair, and he will do a demonstration of ShipConstructor software structure. It should take around 60 minutes for the demonstration, and then I will finish up with some material at the end. Take it away, Blair.
Welcome everyone to this presentation of ShipConstructor structure. The agenda for today's presentation is we're going to do a brief look at setting up a project to work with structure. We'll take a look at some of the core concepts that we'll be using in working with the ShipConstructor module. The bulk of the demonstration today is going to be building up a portion of a frame from scratch with ShipConstructor. And when that's done, then we'll follow up with creating a few assembly drawings and nesting the parts that we created today on some actual plate stock. So project setup. The goal of project setup is to define some of the stocks and some of the preset feature settings, such as corner treatments, flange standards, and so forth, that we want to use when we're actually modeling the parts for our ship. By setting this up ahead of time, this allows us to simplify our modeling, so applying our stocks as we're creating parts or applying features to existing parts is simply a matter of defining the space or parts we want to work with and applying by name the features that we want to apply to those. Also, having our stocks set up ahead of time allows us to standardize the techniques and approaches to our model across the ship. So we have predefined standards, and those are used systematically across the ship design. In ShipConstructor, project setup is done primarily in Manager, and we'll go take a look at a few of the things that, related to what we'll touch on today in doing that. So we'll go to, in ShipConstructor, we go to Manager, and we're going to go take a look at the stock catalog for structure. So the two things that we'll be touching on today are working with plate and profile stock. So our plate stocks are organized by size, by thickness here. So if we take a look at some of the properties for a given stock, we can see we have thickness confirmed here. We have the material, and one of the important properties that the material gives us is our density, and this is used by ShipConstructor to calculate the weight of each of our parts. We can apply color by having different colors for our different stocks. This allows us to visually distinguish the different stocks we've used in our 3D model very quickly. Moving on to the profile stock, some of the properties that we see here. The stocks are organized by type, so we have angle, bulb flat, and a few others. Properties that are important for working with the profile stock. The shape is a very important one. This is the profile that will be extruded along a construction line to represent the part that we're creating. So we can see we've got the various shapes defined. These are user configurable, so you define your own profile. We again see material and color. Another one of the really important properties related to our profile stock are cutouts. So for each stock we can specify cutouts that are applied to when our stiffeners penetrate a plate. And this, by specifying the cutouts ahead of time in Manager, now this allows ShipConstructor to automatically detect the interferences between stiffeners and plates and apply the cutouts. And we'll take a look at this a little bit later in the demonstration today. So some of the other things that we'll be touching on in the demonstration are, we'll be doing some flanges. So flanges standards are set up in the catalog as well. So a flange standard is essentially a preset set of properties that are used to define the shape of the flange. And by setting these up ahead of time, giving them a name, we'll see later on that all we need to do is apply a given flange standard to our plate, and the flange is applied. One other thing we'll see in from the catalog here that we'll be using today are corner treatments. These are fairly simple. Again, it's a named set of properties, so we have a shape and a radius that we apply to for the cutout. So there's a number of other properties, but in terms of what we'll be covering today in the demonstration, it just gives you a sense of the types of things that we'll be working with and where we set them up ahead of time. So we'll be calling on these later on in the demonstration. So with our project set up, we're now ready to move on to actually building the ship model. So in structure, working with all of our parts are created on planar groups in planar group drawings. The three principal planar groups in structure are the frames. These are transverse cross sections of the frame, of the ship, and these progress down the length of the ship. successive slices down the length of the ship. Decks are horizontal slices of the ship, and these usually in location start at the bottom and move progressively upwards. And longitudinal bulkheads are longitudinal slices of the ship that radiate from the center line outwards on either side of the ship. And we'll be working with planar group drawings, and each drawing represents one particular slice at a given location in the ship. When creating plate parts, we'll be working on a construction plane defined by the planar group that we're working on, and we will be creating construction lines on that plane, and defining a plate is simply a process of specifying an area enclosed by a set of construction lines on that construction plane. It's a very simple process. Once we have a plate, there are a number of features we can apply to a plate. We can apply corner treatments. We can have ShipConstructor automatically apply stiffener cutouts. We can add manual cutouts to our plate. And we can also apply flanges, green, and bevels to plate edges as well. So, as we saw, creating plate and working with plate in ShipConstructor is determined by working with construction lines. So construction lines are an important part of structure modeling, and ShipConstructor provides 4 different types of core construction lines. One of them is the hull trace construction line. This represents, it comes into our structure drawings from hull and represents the shape of the hull in our planar group drawing. We have these are the most restrictive type. We can't really do too much with the hull trace because they literally represent where the hull is at that particular location. So those are relatively fixed. We can extend them and we can trim them, and that's about all we can do with them. Offset construction lines are created using AutoCAD's offset command against one of the other types of construction lines. These are extremely useful construction lines as they maintain the offset that we've set from the original. So if the original is moved, then the offset is maintained between that. So any parts that we've defined using an offset construction line will maintain that offset from the original as the original moves around. Planar group plane construction lines are a really powerful construction line and a tool in ShipConstructor. And they represent the intersection of 2 planar groups. So in this case, you can, on the drawing that we're looking at here, we're in essentially a frame. We can see the outline of the hull at that frame location. And we've created a planar group plane construction line that represents the deck TT1400 and where it intersects with that frame. So these are really powerful, partly because they're live construction lines. So they always represent the current location of the deck. So if I move my deck, my TT1400, then when I look into my frame drawing, that construction line is going to move, and it'll now reflect the new location of that deck. Also, any plate that I've defined using that construction line as a boundary or an offset of it will now adjust to the new location as well. So if I have a plate that goes up to that deck and is intended to be welded to that deck, when I move that deck up, my plate will expand upward with it, and any of the features related to it from offsets will also move up as well. So this is a really strong feature of ShipConstructor's associative and parametric modeling. So with that sort of setup, we have sort of some of the concepts down. We'll actually get into modeling our frame. So the first thing we're going to do is we said we have to, in order to work with our structure, we need planar group drawings to work from, because that's what we're going to work on is a planar group. And so we need our frame planar group. What we're looking at here is a structure model drawing, and this is a half-breadth drawing of the hull outline for the unit that we're working with. So if we zoom in a little, we can see that there are already mark lines marked on the frame and on the surface representing each of the frames in this unit. So we're going to build up frame 60 and frame 64 as part of the demo. So to do that, we're going to actually extract the actual mark line polylines from our surface. So we're going to go to extract. So just pick. So now I have actual polylines representing my planar groups, one each at frame 64 and frame 60. Creating my planar group drawings, I simply go to Structure, say Create Planar Group, and I pre-selected my polylines representing the planes that I want to work on. So I have a number of properties I can set now for my planar group. So based on the name of the object that I selected, it suggested a name, which I can pretty much keep. I'm going to just adapt it a little bit. Properties I can set for my planar group are the default thickness throw. So we're going to be working on a construction plane, a 2D construct, but our plate has thickness, so we have to specify which side of that construction plane my plate will, the thickness of my plate will go. So in this case, we're going to set up, I'm going to say for aft will be my thickness, and we're going to set our mark side on the forward side of the plate. Another property we can set is the default assembly for my planar group. And so all parts, unless I say otherwise, will now be created in this assembly. Now, since I've specified two objects on each of the planar groups, it's offering to try and join them together based on a given tolerance. So I'll say, sure, okay, do that. And now we'll repeat the process for frame 64. And now it's just telling me that it's created the two planar groups. So with this done, we're finished with our surface drawing, our hull drawing. So I can now go to Navigator, and we'll take a look at, go to Structure. So we can see we now have the F61_1 and F64_1 drawings that we just created. So these are our frame planar groups. And we're going to open frame 60. And we can see the outline of our hull model here. Now, one of the things I'm going to do before I get too far into this is we can see our hull is split into two lines, and if we look closely at the end, one of the artifacts that sometimes happens with the hull modeling is our hull surfaces didn't quite touch. So in order to work with creating the plate, as we said earlier, we have to define an area entirely enclosed by construction lines. So gaps in our construction lines will give us problems. So I want to just patch this up and make sure that my hull outline is intact. So I can just simply use AutoCAD Command Extend. So another point about ShipConstructor construction lines is that they're designed to be manipulated entirely with the AutoCAD's core command set for working with polylines. So within the constraints of each type of construction line, you just use trim, extend, you can use break command as a way of manipulating the construction lines that you're working with. So here I'm using extend, and from going over this before, I know that neither of them actually overlap, so I have to use the edge option to get my line to extend out, and I extend this one now to join, and now we can simply join them together into a single polyline. So now we can see our hull outline. So this is the one side that we're going to work on with our plate, the outside of our frame. The next thing we need to do is build some context into our, get some context into our frame. So we need to kind of know where we're going, so where we are, so we can orient ourselves. And here we're going to use the mark group intersection command, and this is the command that we use to create the planar group plane construction lines. So I'm working on a frame, so the types of planar groups that intersect this frame are longitudinal bulkheads, and I'm going to bring 2 in here. And decks are the other type that will intersect, and I'm going to bring one deck in, our TT1400. So we can see that the planar group plane construction lines actually are labeled, so we know which of the where the lines are, and we know what they refer to. So we have our deck on our two longitudinal bulkhead lines. So creating a plate, I'm going to set my UCS to match the construction plane or the mold plane of my planar group, so that points that I pick will also be on the construction plane. And my lines are set up now. They're actually defining an enclosed area on this plane. So creating a plate in this new area now is simply a matter of picking the enclosed area that I want to define my plate in. The point I pick, it will become the center point of the piece mark for the plate that I create. So as I create my plate, I can specify a couple of options. The crucial one is my stock that I want to work with. A name is already generated for me here based on the naming convention that we set up in when setting up our project. We can also override. We set up a default for the throw and mark side for the planar group, and I can override these at this point if I want to, but we'll just keep them as is for now. I can also override the default product hierarchy we set up, and I can also specify finishes for my plate here and user attributes as well. So if we've defined some user attributes that apply to a plate, we can fill in values here at this point as well. So we're keeping it simple for today. So now we can see our plate. If we zoom in a little, we can see the construction lines are on the mold plane or the construction plane that we're working with. And we're looking forward in the ship, and we said that our thickness throw direction was aft. So we can see that the plate's thickness is extending towards us or aft from the construction plane, which is how we set up our drawing. So the next thing we're going to do, now we've got a plate, is we can start detailing our plate. The first thing we'll add is some corner treatments. And to do this, I'm going to use the insert corner treatment command. I select the part that I want to add my corner treatments to. And now it's going to offer me a set of corner treatments. And these, as we saw earlier, were set up in Manager as part of our project setup. So all I have to do is select the corner treatment I want to apply and where I want to apply it. And I'm done. So now I have my corner treatments applied. Next, I want to add a manual cutout. I need a lightning hole in my plate, and to add the cutout, it's simply a matter of defining a construction line. To be a cutout in a plate, it has to be a closed construction line, a closed poly line. And then I just add that to the plate as a feature, and it will define my cutout. So I'm going to cheat a little bit for the purposes of the demonstration today. I have, actually I'm going to close my drawing. Save, yes. I'm going to cheat a little bit. I've predefined the construction line that I want to use for my cutout, and I'm going to use a command to copy objects from one planar group to another. And all I have to do in order to do this is specify what frame or planar group I want to apply it to, and ShipConstructor will copy the geometry over and take care of moving it to the appropriate construction plane. So now if I go back to my drawing, my frame 60 drawing, another command I'm going to use a fair amount today on the structure tab is the toggling show solid. So if I'm in a non-wireframe 3D view, I can turn my solid on or off again. And sometimes if I want to work with construction lines and the solid is in the way, this allows me access to the construction line. sometimes for selection, this is an easier way to do it. So adding my construction line to the plate, I'm going to simply use the add objects to part command. I select the part that I want to add it to and the object I want to add. And now if we turn the solid on, we can see we've now defined the lightning hole in our part. I'm getting to the point now where my part is starting to flesh itself out, and the next thing I want to do is I'm going to want to be able to define my part, replicate my part on the opposite side of the ship. Now I'm not going to want to have to redo all the effort that I did to defining the part that we've done so far. What I want to do is I want literally a mirror image of that part. So of course ShipConstructor provides a command that allows us to do this. And this is the mirror about center line command. And all I do is pick the part that I want to mirror, and then it will automatically mirror it about the center line. Now our plate is defined by construction lines, so the mirror command also has duplicated the construction lines used to define the original plate as a way of defining the mirror image plate. So we have mirror images also of our of our 4 construction lines. So this has mirrored the hull outline for us, as well as the longitudinal bulkhead definitions, and it's also essentially extended our planar group plane construction line. So with that done, now we're going to move on. We're going to create a plate in the center. It's going to be only a partial height plate, and we're going to add a face plate on top of that to strengthen it a little bit. So what I want to do is define this plate as a meter gap from my deck above. I want it to be a low. So in order to do that, we're going to use an offset of my planar group plane construction line. Now I can see my planar group plane construction line doesn't quite extend to the bulkhead that I want to use, so we're going to again use AutoCAD's extend command to extend that outwards. So I think I missed it. So, and now what it's telling me here is, since we mirrored the plate part that used this construction line, we've also mirrored the construction line. So what it's telling me here is I have a mirror of my construction line that I'm modifying, and it's just simply saying I'm going to be updating that construction line as well, and there are some parts connected to that that could be modified as well. Since we're not actually changing the geometry, this isn't going to make any difference, but it's just letting me know here. So now if we take a look at our construction line, it does now extend over to the longitudinal bulkhead. So now I can use my offset command to get my meter offset, and we bring the meter down. And I'm just going to trim this down a little bit. So again, just using AutoCAD commands to manipulate my construction lines. Creating my plate now is again just a matter of define my enclosed space, so I just simply pick the space I want to use to define the plate, have my stock, and now if we turn on our solid, we can see we have our plate. We'll add our corner treatments. So, and we've got our plate. I'm going to say you're seeing the piece mark, and I haven't explained this yet, as I hover over or select the part. And what's happening is, so we're looking at it from the thickness throw direction. So we're looking at the plate, and we define the mark side as the forward side of the plate. So if we just rotate the image around, we can see the mark side is actually showing on the opposite side, but it's obscured when we're in the 3D view because of we've got the solid showing in front of it. So now we have our panel, and we're going to add our faceplate. Creating a faceplate is very similar to creating a plate, a normal plate. A few differences are we'll be specifying the plate that we want to attach our faceplate to. So we're using the new faceplate command. We select the plate. Now it's asking me for a construction line along which we'll draw the faceplate or model the faceplate. So similar set of choices here to creating a plate. The dialog's a little bit different, but the choices are largely the same. We've got a name that's been generated for us based on a naming convention. So you can see we're using F here for a faceplate rather than P for our plate. I'm going to use flat bar, 100 by 8 mil, and we can preview the end treatments for my faceplate as well. So I've got end cuts preset here from the last time I was using the command. These aren't the ones I want to apply to my faceplate, so I'm going to change those now so we can see they're correct. I'm going to actually inset the ends of my faceplate a little bit as well, because I'm going to be using O-snaps to model these, and they're going to go right up to the neighboring plate, and I don't want my faceplate to be flush with those. I want them inset a slight bit, so I'm going to set that here. We won't add any green. We have the other thing we can set for our faceplate is the position. So this is how the faceplate sits on the plate it'll be attached to. So center to center, this is what I'm going to choose for this one. We can also choose center to either edge, or we can choose the edge flush with either edge as well. So now I actually draw from one end into the other end that I want the faceplate to go, and then I pick a throw direction for my faceplate, so which way we want the thickness to extend up. And now we have our faceplate, and if we look around we can see it's inset slightly from the edge, and that's what I was looking for. So that's creating a faceplate. Now we can see two of the plates we've defined here have been defined to extend up to this TT1400 deck. Now if we take a look at that deck, we'll actually bring it in and see it in context. And if we look down, we can see that deck is supported by a number of stiffeners, and those stiffeners project through our plate. So we actually need to make cutouts to accommodate these stiffeners. So now we've set up our project. You recall when we looked at the stock catalog that one of the properties we could set for each of the profile stocks was a cutout shape. And so now with actually adding the cutouts for these stiffeners is now quite straightforward. I'm going to just simply go into the Manage Cutout command. I select the part that I want to work with. Now again, this is a mirrored part now, so ShipConstructor is telling me or showing me that it's maintaining the relationship with the original part, and that any changes I make to that part will be reflected across this relationship to the mirrored part. So that's okay, that's what I want. So now it's taking a look. It's gone out to check for the interferences, and it's found my 4 stiffeners. It's showing me that it's a watertight, non-watertight penetration, and what the stiffener stock is that it's using, and it's giving me actually a preview of what the cutout will look like. Now if I want to, I can exclude any of these penetrations from my cutout, automatic cutout, but in this case I'm just going to keep all of them. So now we can see we've applied the cutout. If we zoom out a little and go across, we can see that indeed the mirrored part was updated as well. So again, this is taking advantage of some of the associative modeling properties in ShipConstructor. Now another element that we may want to work with is we set up the definition of our center panel as being an offset from the upper deck. And it may turn out that I actually want to change that relationship. So maybe I want this to be only a 900 mils rather than a 1 meter. So in order to do that, I can actually select my construction line and edit the offset and change it. And you can see now what's happened is the plate has moved up. It's extended up to the new position of my construction line, and the faceplate has moved up as well. So we've got a faceplate attached to a plate. The plate's defined by a construction line that's offset from my deck. So we can see that now the deck, or that everything is adapted by simply moving one of the construction lines. And this has really simplified the amount of work I have to do to adapt to that change. So I think we're finished with our deck in this drawing. So I can pull that out. Okay, so now if we take a look at the two plates on either side of the center, we can see they were defined on the top edge by our TT1400 deck. Now if we needed to move the TT1400 deck, let's say for example a piece of equipment spec has changed and we need to make room for that, for example, moving the deck is fairly straightforward. We simply need to go to the planar group drawing that represents that planar group and run the move planar group command. Now it's a deck, so I can move it either up or down. So we'll move it up 200 mils. And I'm going to save this back to the database. And now we go back to our planar group drawing. And before we bring in the change, I'm just going to draw some reference geometry so we can track what actually did change. Now to bring in the changes, we're just going to reload. Drawing. So we can see a few things have changed here. The first one we'll look at is our planar group plane construction line for the TT1400 deck. Now as we said, this is a live reference to that planar group. So since we've moved the planar group, it makes sense that our planar group plane construction line has moved along with it. Now as part of that, we also defined two of our plates based off of that construction line. So when the construction line moved, the plates have expanded to meet the new location of the construction line. Also, our central plate was defined as an offset of that planar group. So we should have, I think we settled on eventually 1900 mils for that. So if we go down to this, and yes, it's 900 mils. So the other thing we can see is as our deck moved up, there were stiffeners supporting that deck, and those stiffeners were attached to the deck. And those stiffeners have now moved up along with the deck. And along with those stiffeners moving up, we can see that the cutouts for those stiffeners have moved as well. So all of that has been tracked through the associations that ShipConstructor has maintained with those parts. So by setting up our parts with those relationships, we've made changes to the model relatively painless. We've not so far had to do anything in response to raising our deck. So again, one of the strengths of taking advantage of things like the offset construction lines and the planar group plane construction lines. So I'm just going to, before we continue on, I'm just going to switch back and put my deck back to the original location. So we'll move it down, save that, and bring that across. And I can now get rid of my reference geometry. So the last thing I want to do in terms of detailing my deck, my frame, the panels that we're working with here, is I want to add some stiffeners around the lightning hole. So I'm going to just switch around to the mark side of my drawing, And I'm going to use the same technique I used for the cutout. So our stiffeners are going to be based on construction lines, and the construction lines with stiffeners, they provide a path to extrude our profile rather than as a boundary for our part. So I'm going to go, and as I say, I'm cheating similar to the way I did with the cutouts for the lightning hole, and I'm going to bring in my geometry for my stiffeners from another planar group drawing. Now I have to close my original drawing because the replicate object works essentially in the background to update my drawing, and so I can't have the drawing opened at the same time. So I'm going to just say replicate geometry, and then I specify my location, frame 60, and now I can go back and open the drawing. And we can see we've got our construction lines have now been brought in. So I'm going to turn the solids off as we work with these. Now creating the stiffeners is going to be a very similar process to what we did with the faceplate. We're going to run the new stiffener command. We're going to specify the construction lines that we want to work with. We'll do the verticals first. I'm going to specify a plate to attach our stiffeners to. And now we can see we're getting a name generated. We're using our S prefix to the auto number. So with the naming convention we've set up, that's the first stiffeners. We can see our stock. We're using the flat bar 100 by 8. The A2 cutout is what, so A12 cutout is what I want to use for my vertical, so that's okay. I don't need to shorten it or lengthen it. Again, no green, so I think we're okay to go. I can also set product hierarchy, finishes, and attributes again, as with the faceplate and with plate, but we'll keep it simple here for the demonstration. Now, again, we're modifying here a plate by attaching stiffeners to it that is mirrored. So again, ShipConstructor is telling me that it's keeping track of those changes, and because I've declared that mirror relationship, it's going to mirror any changes that I make across as well. So, which is what I want. So, and we'll do the same thing on our horizontals. Select the construction lines, specify the plate. We've got another name generated, our stock. The only change I'm going to make here is I'm going to change the cutout. So again, we see the preview and we create our plate. We're updating the mirrored parts again. And now if we turn on our solids, we can look and we can see that we have indeed created our plates. The end cuts have been set as we've specified. And we can see that the mirrored plate has been updated as well with the changes. So that finishes off those plates. And there's only one more thing I want to do before I finish off my frame. And that is I'm going to add another plate to the side, and I'm going to add a flanged top to that plate. So creating the plate is familiar by now. We're going to add our stock. We won't change any of the defaults. We're going to add our corner treatments. And adding our flange is, again, fairly straightforward because our project was set up with our flange standards. So I'm going to use the add flange command, and I'm going to select, so it's asked me to select an edge on the plate, so not just the plate, but a particular edge that I want to add the flange to. Now all I have to do is select the flange standard that I want. I can set the angle. It's defaulting here to 90. But I can set that to 45 or 30, whatever is appropriate. I can set the flange direction. In this case, I'm going to make it forward. And ShipConstructor is also going to draw a fold line for my flange. So I can specify the style for the fold line. This is set up again in the manager. We can specify the customize the text that we want and set the text size as well. We can also override the flange radius, which was set up as part of the the stock definition as a default. But in this case, we'll keep the default. So now we take a look at our stock. If we turn I can actually turn the production, the toolpath drawing off, and we can see now that we've got our flange applied. So one last thing I'm going to do before I finish off this plate is I don't actually want it to be flush with the deck. I want it to come down slightly at an angle. So I'm going to add another construction line. And now, similar to the way we added the cutout, I'm going to use the Add Objects, select my plate, select the construction line, and we can see now that the plate has adapted to the new boundary. The flange has followed this as well. So if we turn the solid on, one last thing we're going to do, since we've moved our plate down, the cutout, sorry, the corner treatment we've lost. So we'll just add that back again. Turn on our solid, and we can see our new panel shape and with flange. Now, of course, we want to get that, move that over to, or mirror that over to the other side. And we now have our frame defined. The next thing we want to do, if we go back to the beginning of the presentation, we created two planar group drawings. So one was for frame 60, the one we've worked on, and the other one was for frame 64. Now the spec for frame 64 is virtually identical to my frame 60, with the only difference that I need the hull will have a slightly different shape at that point. So we're going to explore how we can take advantage of the work we've done in frame 60 and just simply adapt it to the new frame location rather than having to rebuild frame 64 up from scratch the way we've done with this one. So the first thing we'll do is we'll go and take a look at the frame 64 drawing that we created at the beginning. So, and similar to our frame 60, we can see we've got the hull outline. But if we look at the lines, we can see again they're disjoint. So we'll just clean those up in the same fashion that we did with frame 60. So extend and trim and join these together. And so now we have a single hull trace. So we can save that, and we're going to close it. And the reason we have to do that is we're going to use the same command we used to copy our cheater geometry from the other planar group drawings. We're going to use the replicate objects to other groups command, and that command essentially copies the geometry over in the background, so I can't have the drawing opened at the same time that I run that command. So now we're just going to select our frame 60 geometry, run the replicate objects command, and it's going to ask me to specify where I want to put it. So we're going to say our frame 64. So you can see briefly there was some calculation going on regarding the stiffener. So it's just checking to see if the stiffeners that we have cutouts for still apply in the new location. Otherwise, we've got our copied over, so we can go and open up our frame 64 again. Switch over to a 3D style, visual style. So we can see now our geometry, our frame 60 geometry in our frame 64 drawing. And we can see our new hull outline. So when we defined these plates originally in frame 60, we used our hull outline drawings as our construction lines, and those defined the lower boundary of our plates. So effectively, all we really want to do is to switch the existing construction line with the new construction line. So ShipConstructor has a command that will do exactly that. We go to our construction line section on our structure tab. We're going to do swap construction line, and we specify the current construction line that's being used and the one we want to substitute as the new one. So now what it's showing me here is that with the new construction line, that I have 3 parts that are currently affected by that construction line or using it as part of their definition. So I can choose to update only a portion of them if I want, but I'll keep all of them. Now for each of the parts that we're modifying, it's now showing, because we've got essentially what's happened is when we replicated the parts from frame 60 to frame 64, ShipConstructor again is trying to maintain the relationships. The parts are identical. So we've essentially copied those parts. So it's saying, as it's showing here, that that we have identical copies of the parts that we're trying to work with here. And if I make changes to these parts, it's going to propagate those changes back across that relationship to my parts in frame 60. I don't want to do that in this case. I have to break that relationship because these are not identicals. If it was further inside the frame, that may apply, but on the hull shape, I want to break those. So I'm going to break that connection to the frame 60 drawing. And it's going to prompt me now for each of the parts that's being updated. So I'm going to just break those 3 relationships. So now we can see all 3 parts. It's not visible on this one, on the center one, but we can see that the bottom shape has adapted now to the new hull outline for our frame 64 location. So this is exactly what we want. So that's great. Now on the other side, we were only working with the line that covered half of it, so we need to replicate these changes to the other half of the ship, of the frame. Now if we take a look at the relationships for the parts on the other half now that we haven't dealt with yet, and so we look at, so we don't see a mirror relationship on these parts. In frame 60, remember these were mirrors of the parts on the other side. So what's happened now is we've got an identical relationship to the equivalent part now on frame 60. And so what's happened is, again, the replication, it's an identical to the part in frame 60. It's no longer the mirror relationship here. So what we want is we want to retain that mirrored relationship. So normally, we've done things a little bit differently for the purposes of the demonstration here, but what we would normally do is model our 1/2 of our frame and replicate that first and then do the mirroring across, and then so we could adapt each frame on the half frame and then mirror it across. So to simulate that this time, we're actually just going to delete our frame 64 counterparts and the construction lines that went along with it, and we're going to simulate the mirror first and then, or sorry, the replicate first and then mirror behavior. So we're going to go here, we're going to mirror these parts across to the other side. So now we can see we have our parts with our new hull shape definition exactly as we want. So the one part, if we turn off our solids, we can see that's still giving us a little bit of grief is our center panel. And that's because we've replaced one of the construction lines and we've not updated it with yet another one. So essentially we've got an open, it's not completely bounded by the construction lines, a set of construction lines yet. So in order to make this work, we still need to fix up. We're going to use our swap command again. We're going to specify the old construction line and the new, and it's saying yes, there is one part that needs to be updated. And now we can see that the part's now fully defined. I can actually go ahead and delete my old hull outline from frame 60 because I no longer need that here. And we can see we now have our completed frame 64 as well. So that's as far as we're going to take the modeling part of the demonstration today. The next thing we're going to do is take a look at creating an assembly drawing. So to do that, we're going to need an assembly. So I'm going to open up the product hierarchy. And so one of the first things we did is let's make sure we've saved both of these and refresh my product hierarchy. Just to make sure I've got everything up to date. So when we set up our planar group drawings, both for frame 60 and 64 at the beginning, I set the default assembly as 0208 for those planar groups. So that means all parts I've created have ended up in that assembly. So we can see I do already have a panel definition for P01. So if I go to my frame 60 and I look, I can see here I've got my panel 01, so we can use that panel for that panel assembly to store the parts for that panel definition. So I can go through and I'm going to just keep these open. Go through and I'm going to select all the stiffeners and my plate part. So we can see that the selection has been reflected in the product hierarchy palette as well. And I'm just going to drag those into my P01 panel. So it's just giving me a notification here that by changing the assembly that the parts belong to, and because they have an assembly component in their naming convention, that these parts names is going to be updated, but it's not going to reflect in the drawing until I actually reload the drawing. So we can do that now, just to show that. Let's see. So, and we can see now that the direct assembly component of our naming convention now shows the panel name. And similarly, if we look at the stiffeners, we can see that the stiffeners have the panel name as their assembly component and then their part name as the stiffener ID. So now generating an assembly drawing for my panel assembly is straightforward. We go to Navigator, we go to Assembly section, going to go Create. I'm going to pick a template for my drawing. In this case it's a panel. And I select the assembly that I want to generate, or that I want my assembly drawing to be generated for. This is essentially selecting the parts that will be brought into my assembly drawing. It suggested a drawing name and checked on the file system to make sure that's not overlapping with an existing file name, which is okay. So I click Finish. And now it's going to essentially create a version of my assembly drawing from template, load the parts in, add the BOM, fill out the BOM, and we're ready to go. In this case, it's the orientation's not exactly what I want, so I'm going to just rotate it around a little bit. Actually, so get a little more of a reflective of how we'll be actually working with the assembly. And then I'm just going to add some labels to this one. So we're going to go to our production tab, labeling, and we'll label the layout. And ShipConstructor's automatically added the labels along some label lines reflecting the item numbers in the BOM. If we have a slightly more complicated assembly, then the process is not much different. I've got an assembly we'll do for, let's see, create a new assembly drawing. I'm going to do for an erection stage, and we'll do 07 ES 0 erection stage 07. Now, if we look at this, so we actually can generate a large number of assembly drawings all at once. Just for the purposes of the demonstration, though, I don't want to take the time to do that. So I can actually filter these out, And we'll turn those off, and I'm only going to generate it for my erection stage 70 for the direct assembly that I'm working with. Now I only have one. It's being brought across. I'm going to update the name a little bit. Name's already in use, so we'll add a suffix. And so similar to my panel assembly, now I'm going to be generating the erection stage assembly. And that's all there's required to it. So that's assembly drawings, and the last thing we're going to cover in the demonstration today is we're going to nest the parts that we created today. So we're actually going to place them onto, allocate some space onto some plate parts ready for cutting. So to do that, we're going to go to our nest drawing section in Navigator. We're going to create a new nest drawing. So we're going to create U02. So we're going to do it for our 8mm plate. I already have one, so we're just going to use a new one for the demo so that we can keep it clean. So we select the stock that we're going to be nesting in this drawing. And now it opens up, and I've got a clean nest drawing. To add parts to this, all I need to do is go to my Nest and Profile section on the ribbon, go Insert Part. And so what I'm going to be working with here is we're going to do automatic nesting. Manual is definitely an option, but we're going to use the automatic. Another option I have here is I've been consistently using my 100x8 flat bar, and so I have the option here of nesting my flat bar as part of my plate instead of out of profile stock. So, and for today, that's what I'm going to do. So now with that filter set, we can see that if we look into our 0208 assembly, we can see that we have all of the plate, the stiffeners, the face plates that we created, one in each panel, or sorry, one in each frame, are all available. So I can select all of those, and I select OK. So the next thing it's offering us here is now which plates do we want to nest our parts on? So the option here, I've defined in my inventory, I have two types of plates. I have a 25 by 12,000, 2500 by 12,000, a 3000 by 12,000 plate. And I have a fair number of those, but it's also showing that I have two remnants. And remnants are, so when I was working on a previous frame or unit, I was nesting my parts, and I had a section of a plate left over, a reasonable sized chunk of plate left over. And obviously I don't want to waste that plate. So I can actually label that as a remnant in a way that I can keep track of it, and ShipConstructor can keep track of it. And then now when I've come to this point, I can say, okay, I have these remnants, and I can actually reuse those and nest my parts onto those. So that's what we're going to do here. I can control, if I wanted to, I could move the raw plates up higher in the priority so that I would use up those before my remnants, but no point in using the new ones while I still have remnants that I can draw from. So I also specify my template drawing for the nest, and then I select OK. This is just simply some layout options. Do I want to go across and up, or up and across? And we'll just keep the default. So now it's calculating the nest, giving us some statistics in terms of the plate utilization, and we have our nest drawing. So if we zoom out, we can see, so it's managed to fit all of the parts onto the two remnants that we had available to us. One was relatively small, one was slightly larger. So, and if we zoom in and take a look, we can see we have the middle side panels that we've defined. We've got a face plate here. We have several of our stiffeners, another face plate, more of our stiffeners across here. And we can see on our other plate, rest of our stiffeners and side panels, and we can also see the outer panels as well defined here, and with some of our center panels. So that's what all there is to nesting parts. Obviously, there's our manual options available, and if you need to jig some things around, you can do so manually as well. But the automatic nesting can save an awful lot of time. So that's the end of my presentation. The key takeaways that I hope you'll get from the presentation today are the ease of use of structure, that once we have our projects set up appropriately, that the modeling of our structure components, our frames, our decks, and so forth is fairly straightforward. We work primarily in a two-dimensional world, defining the parts we need using construction lines, and then adding features to the plates that from standards that we've already defined in our project. The other thing is the set of powerful and flexible construction lines, especially the offset and the planar group plane construction lines, in allowing for the associative modeling of the parts in your ship. This minimizes the amount of effort that's required to adapt to changes in the ship design. So in terms of assembly, drawing, creation, that it's simple, wizard-driven, and that multiple assembly drawings can be generated at the same time. And also, lastly, just the help that automatic nesting can give you in terms of speeding up your the nesting side of your project and getting ready for your actual cutting. So with that, I'm going to send it, actually we're going to say that this is the end. Norm will take it over for the conclusion of the presentation. And I really thank everybody for dropping by. Take care, everyone. Bye now.
Well, thank you, Blair, for that demonstration of ShipConstructor structure. It's very comprehensive. I'd just like to finish off with a few wrap-up slides. Bear with me. I just want to highlight some of the key benefits of what we've just seen. One of the things that ShipConstructor structure manages very well is change. The associative modeling tools found in ShipConstructor structure product allow changes to be made to existing designs in a predictable and manageable way. Since a change in a portion of the product model will cause modifications in other portions, ShipConstructor outlines what those modifications will be. This provides a true understanding of the impact of any change. That's part of the real world. Intelligent models. Associations in the 3D project model are automatically created as the user employs standard AutoCAD commands during the design process. This provides the benefits of an associative modeling environment without the extensive training experience that is often required. People like that. Standards-based design. The 3D project model is built using a range of configurable shipbuilding standards, including flanges, profile cutouts, standard brackets, stiffener, etc. The required standards are either selected manually by the user or automatically selected according to predefined associative rules for each project. As these standards are changed in the library over time, the project model automatically reflects their current state, which is pretty handy. Of course, ShipConstructor provides an array of marine-specific tools that are required in the detailing of production drawings. These tools include configurable bombs, automatic labeling of piece parts, spools and assemblies, spool dimensioning, weld symbols, quality control, to name a few. These capabilities build on and work together with the 2D drafting capabilities provided by AutoCAD, which, as you all know, is a world leader in this space. Associative product design. Production information, including expanded flange information, stiffener mark lines, bevel information, and such, is automatically created from shipyard standards contained in the project library as the 3D model is built. The production information remains associatively linked to the related elements in the 3D project model as changes occur. So again, managing change associatively. And finally, design reuse. Combination of standard assemblies and the capabilities of WorkShare allow existing work to be leveraged. Originally, we had the project split and merge. Some of the people who are more experienced over the years We now redefine that as a product line under the workshare title. This results in a significant reduction in engineering hours, of course. These tools allow the reuse of individual portions of the project model, entire blocks, and the corresponding production drawings or entire projects. So the product, of course, has been available since the beginning of ShipConstructor, essentially, but there are a couple of twists to it. We have the modules editions. Base product is standard, premium, ultimate, which are based on part counts, and ultimate being unlimited part counts. It's also available as part of our suites, the whole structure suites. So you can see here the whole structure suite standard edition and premium edition, as well as the outfitting suite, the premium and ultimate editions. All suites allow the creation of an unlimited number of parts or objects within the included products. The suites are really designed for smaller to medium-sized firms who have medium to large projects. Large firms with large projects generally go by the modules. And just thought we'd display the suites comparison chart so you can see what's comprised in each of these, the ShipConstructor whole structure suite as well as the outfitting suite, and of course our Ultimate Edition. This information is available on our corporate website, of course. Questions and answers. Of course, we encourage you to submit questions to us. If you want to have an open discussion, we encourage you to use the Augie Marine Forum. You see the URL here. If you are a Nexus subscriber or a ShipConstructor subscriber, certainly can ask questions through Nexus. Or you can also contact your dealer or local representation for SSI in regards to training programs, licensing, and sales. One of the things we're trying new is to leverage social networks. So we have also started up a Twitter account that uses the # SSI webinar series for discussion. So anybody who feels inclined and has a Twitter account, you certainly are free to go there. And we will be trying to use these to promote both upcoming sessions as well as to continue the discussion of past sessions. And here's our full list of almost everything we have, social networks, various social networks. So I'd like to wrap it up there. Thank you very much for your attendance.